Section 3.1 exercises. Problem 1. We are asked to graph the quadratic function, the negative of x minus 1 squared plus 4. To do this, we will use the standard form f of x is equal to a times x minus h squared plus k. The a value, which is negative 1, is less than 0, and that implies that the shape of the graph will be like this. The vertex is hk, and for us, h is 1 and k is 4. And as you see, this will be the maximum point. The vertex will be the maximum point. We also need the x-intercepts, and to do that, we let the y value be 0. So that means we have to solve the equation 0 equals negative x minus 1 squared plus 4. So to do this, we'll take the x minus 1 squared to the left, making it positive. That equals 4. And then taking the square root of both sides gives us x minus 1 equals plus n minus 2. Therefore, x is equal to 3, given the intercept 3, 0, and x is equal to negative 1, given us the intercept negative 1, 0. We can also find the y-intercept. And to do that, we make the x value 0. So we have to find f of 0, putting 0 in the function. Negative of 0 minus 1 squared plus 4 gives us negative 1 plus 4, or 3. So that is the point 0, 3. Transferring this information down here on the graph, we will have the y-intercept being 0, 3. 1x intercept is 3, 0. Another x-intercept is negative 1, 0. And finally, the most important point, the vertex, is at 1, 4, right here. And draw that in like that. Problem number 2. We're asked to graph a different quadratic function in a different form. So we will use the standard form f of x is equal to ax squared plus bx plus c. For us, the a value is negative 1. That is also less than 0, so that implies that the shape will be like the first problem, like that. In this form, we can find the vertex. And the vertex has an x and a y coordinate. The x coordinate is minus b over 2a. Putting these values in gives us negative 4 over 2 times negative 1, which is 2. The y coordinate of the vertex is f of 2. So we'll find f of 2. Substituting 2 into the function will give us negative 2 squared plus 4 times 2 plus 1, giving us 5. So the vertex is 2, 5. Now we need to find the x-intercepts. And to do this, we're going to use quadratic formula, since the original quadratic function does not factor. So x is equal to negative b, so negative 4 plus or minus square root b squared, 4 squared, minus 4 times a, negative 1, times c, which is 1, over 2 times a, which is negative 1. Working this through, we find negative 4 plus or minus the square root of 20 all over negative 2. And that will result, after we simplify, 2 plus or minus root 5. So that gives us two values for our x-intercepts, approximately negative 0.2 and 4.2. So that gives us coordinates negative 0.20 and 4.20. And lastly, we can find the y-intercept here. Y-intercept, making x0, compute the value of the function when x is equal to 0, and we get 1. So the y-intercept is 0, 1. Let's transfer this information down on the graph. The y-intercept is at 0, 1, right here. X-intercepts, negative 0.2, right about there, and 4.2, right about there. And the most important point, the vertex, is at 2, 5, and that'll put us right about there. So in that small space, we will draw our parabola. Last question is to find the function's domain in the range. And the domain is the values of x we can use in the function. Since it moves infinitely far left and right, the domain is all real numbers, meaning from negative infinity to plus infinity. The range, however, is restricted since we have a maximum y-coordinate here of 5. So the range will be as far below the x-axis as we want, up to 5 and including 5. So we use a square bracket there to indicate that. And that's problem 2. Problem 3. Determine without graphing whether the given quadratic function has a minimum value or a maximum value. Well, we do this by looking at the value of a. The value of a is 4. That's a positive value, so that implies that the shape will be this way. And right there is our vertex, which is the lowest point, so that is a minimum. Quadratic function will have a minimum. Let's find that minimum value and determine where it occurs. So to do this, min or max occurs at the vertex. So we need the x coordinate of the vertex, the negative of b, b is negative 16, divided by twice the value of a, which is 4. And that gives us an x value of 2. The y value is then f of 2. So putting 2 into the function, replacing x by 2, we'll have 4 times 2 squared minus 16 times 2 plus 1,000. And that will give us 984. So the conclusion here is the minimum is the y value, 984, and where it occurs is the x value when x equals 2. And that's problem 3. Problem 4. The vertex of a parabola is also called the turning point. Is that a true or false statement? That statement is true. Turning point is a change of direction. And a change of direction occurs if the parabola opens up in this shape, moving from decreasing to increasing. And if the parabola opens in this fashion, then that is a change of direction moving from increase to decrease. And that concludes section 3.1 exercises.